What if I told you that an object traveling at 200,000 miles through our solar system just restructured itself in real time, and the physics we use to explain comets cannot account for what we are seeing? That is not a theoretical question. That is what happened to interstellar object 3I Atlas between November 28th and December 2nd, 2025. I am Avi Loeb, theoretical physicist at Harvard University and founding director of the Galileo project. And I need to show you something that has left my colleagues deeply unsettled. At 1437 UTC, the Nordic Optical Telescope in the Canary Islands captured images that immediately contradicted every prediction we had made about this object's evolution. 3I Atlas, which had been a diffuse, irregularly shaped body just 4 days earlier, now displayed sharp geometric boundaries, repeating brightness patterns, and what appears to be coherent planar surfaces. This is not a processing error. 3 independent observatories, the European Southern Observatory's Very Large Telescope, the Gemini South Facility in Chile, and NASA's Hubble Space Telescope, all confirmed the same structural shift within 18 hours of each other. Let me be extraordinarily clear about what makes this unprecedented. Comets do not become more organized after intense heating. They fragment, they disperse, they lose coherence. The thermal stress from approaching the Sun at 126 million miles, where 3I Atlas reached perihelion on October 30th, should have shattered this object into chaotic debris. Instead, something fundamentally different occurred. The object appears to have shed its outer layers and revealed an interior with mechanical integrity that we have never documented in any natural body. I have spent the last 72 hours analyzing the photometric data with my team at Harvard, and the numbers are unambiguous. The light curve of 3I Atlas has transformed from a noisy, irregular pattern into a stable periodic signal with a precision of 0.03 magnitude variation. That level of consistency indicates surfaces that are not random. They are aligned. They are reflecting light in predictable geometries as the object rotates with a newly stabilized period of 4.2 hours. Before perihelion, the rotation was chaotic, tumbling, what we call non-principal axis rotation. After the transformation, it is spinning like a solid body with a fixed axis. That is not what loose rubble does when it loses mass. On November 15, 2025, when 3I Atlas was still 195 million miles from Earth, images from the Pan-STARRS telescope in Hawaii showed a blurred coma extending 124,000 mi in diameter. The boundary between the nucleus and the surrounding gas was indistinct, exactly what we expect from a small icy body sublimating volatiles. By December 3rd, that coma had contracted to just 41,000 miles. And more importantly, the nucleus itself now displays edges, not the soft eroded contours of a melting snowball, but straight lines, multiple straight lines intersecting at angles that repeat across the visible surface. Dr. Jane Lu, who co-discovered the Kuiper belt and is now collaborating with the Nordic team, released a preliminary analysis yesterday, stating, and I quote, "The geometric features observed are inconsistent with any documented erosion pattern in cometary bodies." She is being diplomatic. What she means is that nature does not carve straight edges into random piles of ice and dust. Not at this scale, not with this precision, and certainly not in the span of 96 hours. The spectroscopic data adds another layer of complexity that my team flagged immediately. Observations from the James Webb Space Telescope on November 27th detected elevated carbon dioxide sublimation at 4.4 million pounds per second. That rate implied the object was losing approximately 10% of its total mass per week. An explosive outgassing event that should have destabilized the entire structure. Yet when JWST observed again on December 4th, the sublimation rate had dropped to 890,000 pounds per second, an 80% reduction. Simultaneously, the surface brightness in the infrared increased by 23% in regions corresponding to the new geometric features. This is where standard physics breaks down. If material is actively venting from the surface, brightness should decrease as dust obscures the nucleus. Instead, we are seeing the opposite: brighter, sharper, more defined surfaces appearing exactly where the most intense outgassing occurred. The simplest explanation, and I stress simplest, is that the outer shell was composed of volatile rich material that vaporized completely, exposing a deeper layer with fundamentally different properties: higher albedo, greater structural integrity, and a composition that reflects infrared radiation more efficiently than the original surface. But here is what troubles me most. The new surfaces are not uniformly bright. Analysis of the rotation phase photometry reveals at least 7 distinct brightness zones, each separated by narrow, darker bands that appear linear when accounting for the object's curvature. These bands are only 300 to 500 Faf wide based on our resolution limits, yet they extend across observable arcs spanning thousands of feet. In terrestrial geology, we see similar patterns in layered sedimentary rock or in crystalline structures formed under uniform pressure. In both cases, the linearity emerges because the material organizes along planes of minimum energy. The question we must confront is whether interstellar space across millions of years of cosmic ray bombardment, micrometeorite impacts, and thermal cycling between star systems can preserve such ordered internal structure in a small body less than 1 mile in diameter. Our models of cometary formation in protoplanetary disks suggest that these objects are heterogeneous aggregates, loosely bound mixtures of ice, silicate, dust, and organic compounds. They are not crystalline. They are not layered in ways that produce coherent geometry when exposed. Yet, that is exactly what we are observing. I must emphasize that I am not claiming this is artificial. I am stating that the behavior does not match our current understanding of how natural interstellar objects evolve, and when data contradicts theory, we have a responsibility to examine both possibilities. The theory is incomplete or the object is not entirely natural. NASA's Jet Propulsion Laboratory has been conspicuously silent. On December 5th, I submitted a formal data request to access the full resolution images captured by the Deep Space Network's radar observations of 3I Atlas conducted between November 30th and December 1st. Those observations have a spatial resolution of approximately 250 ft, sufficient to resolve the surface features directly rather than inferring them from brightness variations. As of this morning, I have received no response. The standard processing time for such requests is 48 hours. It has now been 72. When I reached out to colleagues at JPL privately, the response was evasive. One senior mission scientist, who I will not name because they requested confidentiality, told me that internal review protocols are being applied due to the unusual nature of the findings. That phrase, unusual nature of the findings, is not standard scientific language. It is bureaucratic deflection. What findings could justify withholding data from the broader astronomical community during the narrow observational window we have before this object fades beyond detection? Let me walk you through what happened structurally. Before perihelion 3I, Atlas exhibited what we call a diffuse scattering profile. Light reflected from the surface was distributed broadly, indicating either a rough porous texture or a surrounding dust cloud obscuring the nucleus. The images were fuzzy, not because of telescope limitations, but because the object itself lacked sharp boundaries. On November 11th, processed frames from the Nordic Optical Telescope showed the coma expanding symmetrically at 310 miles per day, forming what observers called a ghost shell, a faint ring of gas and dust surrounding the core. By November 28th, that shell had dissipated almost entirely. The coma thinned, and for the first time, we could see the nucleus clearly. What we saw was still irregular, still chaotic, still consistent with a fragmenting comet. Then, over the next 4 days, something changed. The irregularity resolved into structure. Edges appeared. Brightness zones aligned with rotational phase. The overall silhouette became coherent. Dr. David Jewett, at UCLA, who has studied more comets than perhaps anyone alive, reviewed the transformation sequence and made a statement that stunned me. He said, "If I did not know this was an interstellar object, I would assume these were images of two different bodies." He is right. The before and after profiles are so distinct that if we encountered them separately, we would classify them as different objects entirely. The jets provide additional evidence that the interior is not uniform. On November 13th, observations from the Virtual Telescope project in Italy recorded at least 7 separate jets emanating from 3I Atlas distributed asymmetrically across the surface. This is typical for comets. Sunlight hits random patches. Volatiles sublimate. Jets form wherever the surface is weakest. However, after the transformation, the jet distribution changed. By December 3rd, imaging from the European Southern Observatory showed only 4 jets, but each one was aligned with the newly visible geometric boundaries. This alignment is significant. If the jets are responding to structural features, it means outgassing is no longer random. It is being channeled along preferred pathways, either because the surface has developed fissures that guide material flow, or because the interior possesses some form of mechanical anisotropy, a directional strength that concentrates stress along specific planes. Both explanations require an internal structure far more organized than a loose aggregate of ice and dust. I want to address the speculation directly. Some observers have noted that portions of the new surface resemble what they describe as panels or tiles, flat regions separated by narrow gaps. These descriptions have circulated widely on social media, often accompanied by claims that the object is clearly artificial. I must be precise here. Visual similarity is not evidence. Minerals, especially those formed under pressure, routinely produce flat cleavage planes and sharp edges when fractured. Ice crystallizing in microgravity can form geometrically regular structures. Even some asteroids, when imaged at high resolution, display unexpected linearity in surface features due to internal stress relief. What makes 3 Atlas different is not the appearance of geometry alone, but the fact that this geometry emerged suddenly after the object was subjected to extreme thermal stress. Natural processes can create order, but they typically do so over geological time scales or during formation, not in 96 hours during active sublimation. However, there is a physical mechanism that could explain this spontaneous self-organization in systems far from equilibrium. When materials are heated rapidly, internal stresses build up. If the material has layered or composite structure, releasing those stresses can cause realignment into configurations of lower energy. Crystals do this. Minerals under tectonic pressure do this. And certain ices, when subjected to thermal shock, can reorganize their molecular lattice into more stable arrangements. If 3 Atlas contains such materials formed perhaps in the protoplanetary disk of a distant star under conditions very different from our own solar system, then the transformation we are witnessing could be entirely natural. It would simply represent a class of interstellar object we have not encountered before, one capable of undergoing structural phase transitions when heated. But we must also hold space for the alternative. If the interior of 3 Atlas contains remnants of manufactured material debris from a technological system that has eroded over millions of years in interstellar space, then certain signatures might persist. The tendency to form flat surfaces, internal layering that appears engineered, jets emerging from structural boundaries, rotation stabilizing rather than destabilizing after mass loss. None of these features prove non-natural origin individually, but collectively they form a pattern worth investigating rigorously. The next 30 days are critical. On December 19th, 3I Atlas will reach its closest approach to Earth at 167 million miles, providing the best observational window we will have before it fades. The Hubble Space Telescope has scheduled high-resolution imaging sessions starting December 15th with spatial resolution sufficient to resolve features as small as 335T. If the straight edges we are seeing are real, Hubble will confirm them. If they are artifacts of lower resolution imaging or atmospheric distortion, Hubble will clarify that as well. JWST will conduct near-infrared spectroscopy on December 18th and 22nd, mapping the thermal and chemical properties of the new surfaces. If deeper layers are being exposed, their composition should differ from the original surface detected in August. Specifically, we will be looking for variations in carbon dioxide, water, ice, and the silicate dust ratios across different brightness zones. If the object is layered, those variations should correspond to the geometric boundaries. Here is what I find most frustrating about this entire situation. We have an unprecedented opportunity to study an interstellar object displaying behavior we cannot fully explain. And instead of mobilizing every available resource, we are caught in bureaucratic delays and institutional caution. The data exists, the telescopes are operational, the object is observable, yet access to critical information is being restricted, and the public communication from major space agencies has been minimal. This is not how science should operate. Transparency and open data sharing are foundational principles. When anomalies appear, we investigate them collectively, not behind closed doors. The silence from NASA is particularly concerning given that JPL has some of the highest resolution radar data available, data that could immediately resolve whether the geometric features are real or illusory. I want to be clear about my position. I do not claim to know what 3I Atlas is. I claim that we do not know what it is. And that uncertainty demands rigorous investigation, not dismissal. The transformation is real. The structural coherence is real. The alignment of jets with newly visible geometry is real. These are observations and not interpretations. What we must do now is follow the evidence wherever it leads. If the object is natural, we will expand our understanding of how interstellar materials behave under extreme conditions. If it is something more complex, we will confront a reality that challenges every assumption we hold about our place in the universe. Either outcome would be profound. Science progresses not by protecting comfortable explanations, but by testing every hypothesis the data allows. 3. IATLAS has given us data that challenges our models. Our responsibility is to respond with curiosity, precision, and intellectual honesty, not with silence, not with evasion, and certainly not with premature conclusions designed to preserve existing frameworks. The universe is under no obligation to make sense according to theories developed from studying objects within our own solar system. Interstellar space is vast, ancient, and filled with processes we have barely begun to explore. When something unexpected arrives, our first response should be fascination, not fear. I will continue analyzing every piece of data as it becomes available, and I encourage everyone watching to follow this investigation closely. Subscribe to stay updated as new observations are released. Share this information with others who value transparency in science. And most importantly, ask questions, demand answers, demand access to the data that taxpayer-funded agencies are currently withholding. Because if we allow this moment to pass without full investigation, we may never know what 3I by Atlas truly is. And that would be the greatest failure of